All right, so we need to talk a little bit about something that we call bond energy, okay? And bond energy is where energy tends to be stored in a system, a chemical system. So let's go ahead and take a look at this. This is a video.
What's sound?
There is no sound. Or if there is, it's quiet.
Are we gonna do that?
Just shh.
Did you film this?
Shh.
What is that?
Shh. Shh. Now watch this. Watch. Okay, now let me talk through that, okay? So there was this blue colorful crystal, right? Some of you might even say it's beautiful, okay? And then what happens is that we added heat. So we added heat and it went from blue to like that chalkish color gray, which was gross, right? Inside that particular compound, it was a crystal that has a little bit of water molecules trapped inside of it. And when we heated it, we evaporated the water, essentially, okay? And then once it cooled down, you had just this grayish colored crystal, yeah? And so what they did is they added a little bit of water, and when they added a little bit of water, heat was given off. And we saw that heat because the color change occurred again, but you saw steam being given off. Did you see that?
Yeah.
Okay, so those are essentially examples of endothermic versus exothermic reactions, which we have to talk about a little bit more in detail. Now, in endothermic reactions, okay, bonds are mostly breaking, and more energy is on the reactant side of the equation. So bonds are mostly breaking, and there is more energy on the reactants. This is the part where you should probably write this down. This is the part where you should write this down.
It's a dry erase mark too. You should have done that later too.
Now, so if bonds are mostly breaking, and energy is mostly on the reactant side of the equation, the other thing that I want you to write here, is energy is absorbed. So I want you to write under the endothermic, energy is absorbed, okay? That's the other thing I want you to write here. Can I move on?
I don't want to.
With exothermic reactions, bonds tend to be forming, and the energy is mostly on the product side. Okay? And the energy is mostly on the product side. So what that should look like, in this case, the third thing I want you to write down here is that energy is not absorbed, energy is given off. Or released. Okay? So with endothermic reactions, energy is absorbed. With exothermic reactions, energy is released.
You want me to write down exothermic? Down this.
Under exothermic, I want you to write energy is released. So far, so good with that.
Wait, read it right there.
Underneath exothermic, you write this, because underneath endothermic, you were supposed to have written energy is absorbed. So one more time, I would write energy is absorbed here. I would write energy is released here. Okay? Can I go on? Now, endothermic reactions in chemistry tend to absorb energy from the environment. Now, let me try to explain that. They require energy to be put in. They require heat. Now, let me give you an example. So you're in the gym class, right? And you get a boo-boo on your knee, right? and Binabos stops the entire gym class, and he comes up to you and he pats you on the back and says, there, small child. Let me make you feel better. Mr. Binabos is one of the most empathetic. Same. There, small child. Let me make you feel better. And then they go back into their magical room that's off to the side of the gym, and they go back to their office. And in their office, they produce this cold pack, right? And that cold pack has got the water inside of it, and then you pop the bubble inside of it, and it gets instantaneously cold. You know what I'm talking about? You ever seen those cold packs like that before?
Yeah.
I said the same. They're both going to do the same thing. Now, what ends up happening, though, is that inside this little piece of plastic, inside the chemical cold pack, is a chemical. That chemical, when it mixes with water and dissolves, it absorbs heat from the surrounding. So if you put that cold pack on your face, okay, what actually ends up happening is it's actually drawing energy from your flesh into the system to keep it cold. What I'm getting at here is that your face feels cold because of the energy of your face is being pulled into the dissolving of that substance. So endothermic reactions are pulling energy from the outside. Does that make sense? Okay. So temperature goes down. In an exothermic reaction, energy is released into the environment. You should probably write some of this down. Temperature of the environment tends to increase. Oops, I got to go back. So this would be an example of me taking Josh's note packet and lighting it on fire. Okay? Well, it's garbage anyway, so we're good. So what I'm going to do is I'm going to light it on fire, and you would feel the heat coming off of it. Yeah? Exothermic reaction. Does that make sense? Yes, sir. What, you on your second course?
Let me get some more.
You finished the flips and now you're into like gummy things?
Gummy.
Course 2?
All sugar, all sugar.
All sugar all the time. Can I go on now?
Of course. Wait, just kidding. I lied.
Oh my gosh.
Just kidding. You can go.
So now. The next thing we're going to look at is going to look at a data table. That data table is going to look remarkably similar to the lab that you guys were working on yesterday. But you're going to finish the lab today. Okay, can I go on?
Right now?
So now, here's the thing. I want you to look at this situation and try to decide what's happening in terms of exothermic or endothermic. Now let's take a look. So if I started with something called sodium acetate, mass of 5 grams, the initial temperature of the sodium acetate was 13.6. Its final temperature was 18. So it increased in temperature. So the change in temperature is telling me that this is an exothermic reaction. The system absorbed energy, exothermic reaction. Or gave off energy, rather, exothermic reaction. Okay? In the case of the calcium chloride, the change in temperature was positive again. Exothermic reaction. In the case of the sodium carbonate, positive temperature change. Exothermic reaction. However, when the temperature is negative, that is an endothermic reaction. Now, I'm going to try to show you a diagram to help illustrate this better. If you haven't done so already, you should probably copy this down along the side of this table here so that you can review this at your leisure in the future.
You're a lab now.
What now?
You're a lab
No.
So I want to take that long.
Let me get the star first.
You You might want to ask like why or something.
Yeah, I'll find out.
All right, can I go on now? All right, now these energy diagrams. Pull A and B.
Are we gonna have to do LOL charts?
Just hold on.
Oh, that means yes.
Hold on.
I'm gonna drop it.
So watch this. Watch this. Watch this. Here I have. This is energy of the system, and this is how long the system is going it for. Okay. Here's the energy of my reactants. Note the energy of my products. Okay. I have my energy of my products have more energy than the energy of my reactants, which means that this is endothermic. Okay? So because my products have more energy than my reactants, there's energy that's absorbed. This is endothermic. You should probably write this down.
We do in English.
For diagram B, we have reactants with a specific energy and products which appear to have less energy. So energy was not absorbed, but the opposite, energy was released. So when you see a diagram that looks like this, that means you have an exothermic reaction. So long story short, when products have more energy than reactants, it's endothermic. And when products have less energy than reactants, it's endothermic. Questions about that? Questions about that?
No.
Okay. Now, your homework is worksheet 6, which is endo and exothermic worksheet. Okay? But we have to go back and collect some lab data now. You should have written this down. Sir.
What's that? I mean, that's
Vinegar
in baking soda.
and baking soda.
Everyone knows that.
You said, what's that?
You know what it does. Doesn't it like explode? Well, not
Don't worry about it now.
explode. Same thing.
Can you send that file to me? Can you share this with me?